Linear equations in one variable. All right, before we begin this topic, let's first explore the three types of equations that we will encounter in this class. The first type is called an identity. And if you look at this paragraph here, it's showing a very ugly equation. But if you messed with it a little bit, uh, you would see that you have identically the same thing on the left as you do on the right. The second equation, 5 plus 3 equals 8, obviously is also an identity because 5 plus 3 is 8 and 8 equals 8. So what they're trying to demonstrate here is that when you have uh, identical expressions on either side of the equal sign, this is going to lead to an identity. And if there's a variable in the equation, then any value of that variable, any x or any y or whatever, will work. So there are infinite many solutions in an equation um, of this type. The second one, letter B, is called a contradiction. And if you take this equation t plus 3 equals t and mess with it a little bit, you'll see that the t's cancel out, which leads you to the statement 3 equals 0. Well, this is false. 3 does not equal 0. So this is what we call leading to a contradiction. So when you're solving an equation and it leads to a contradiction, we know that there is no solution for that equation. And we can express this as the empty set, since no value for t satisfies the equation. There's nothing I can plug in for t to make that a true statement. Okay, and then the last type is the most common type, the one that we encounter most, and that is a conditional, where there is actual solutions. So they use the example x squared equals 9 as a conditional equation because this one you'll learn later on in this course, or you may have already learned. This one is solvable. I can solve it by extracting square roots, and I find that x is equal to plus or minus the square root of 9. So the solution set is negative 3 and 3. So we can find values for x that make this a true statement, and this set of solutions is finite, so we call this conditional. And in this class, this is going to be the most common type. We're usually solving for x, trying to find what it is. Okay, so we will use these three types throughout the course. But we're going to start with linear equations in one variable. So let's define a linear equation in one variable. A linear equation in one variable, say the variable x, is an equation that can be transformed into the form ax plus b equals 0, where a and b are real numbers and a is not equal to 0. Such equations are also called first degree equations, as x appears to the first power. Okay, we will talk about degrees of an equation later on in the course, but this is our first encounter with that definition. All right, so let's solve linear equations in one variable. So take a look at our first example. Now, I'm going to assume that you have encountered linear equations at one or another time in your life, so I'm going to go through these kind of quick. Remember that you can pause the video if you're getting confused. Now, I will not skip steps, but I am going to go through it kind of quickly. So the first thing we need to do is get rid of our parentheses, so I'm going to distribute 3. So that gives me 3x minus 6 plus 7x equals, bring down my 1, and now I'm going to distribute negative 2. So that's minus 2x. And negative 2 times 1/2, the 2's cancel out, so I get minus 1. Now combine like terms, 3x plus 7x is 10x minus 6. 1 minus 1 is 0, so I get negative 2x. And now we're going to combine like terms. I'm going to add 2x to both sides. And this gives us 12x minus 6 equals 0, which is the form that's in that definition. Now, you could have subtracted 10x to both sides. You just want variables on one side, numbers on the other, so you can find the value of x. So I'm going to move my 6 by adding it. So 12x equals 6. Divide by 12. So x equals 1/2. And again, pause the video anytime and try the problem yourself. I'm going to distribute 3. Now, notice that I have the same variable on both sides. Just one of those instances where something's going to happen. So subtract 3x. And the x's cancel on both sides. And it leads to a contradiction. So this is a contradiction and there are no solutions. And you can use the symbol empty set. Okay, this next example has fractions in it, so I'm going to demonstrate canceling out fractions. And I do that by multiplying the whole equation through by the common denominator. So the common denominator between 6, 2, and 3 is 6. So when I multiply 6 times y over 6, that's going to give me 6y over 6. And then 6 times 2y minus 1 over 2. And 6 times y plus 1 over 3. Now reduce. That gives me a y plus 3 times 2y minus 1 equals 2 times y plus 1. Now we've gotten rid of the fractions, so now we can distribute and get rid of our parentheses. So I have y plus 6y minus 3 2y plus 2. Combine like terms. 7y minus 3 equals 2y plus 2. Combine like terms. I'm going to subtract 2y to the left. So 5y minus 3 equals 2. Now I'm not going to put this in that form, ay plus b equals 0. I'm just going to go ahead and solve it by adding 3. And then divide by 5. Okay, so the next one's got decimals in it, and you are allowed to use a calculator in this course, so I encourage you to use a calculator. You can also cancel out decimals by multiplying by the power of 10. That power is the most decimals that you have. So in this case, I have 2 decimals in each of these, so I would multiply by 100 or 10 squared. But since we can use calculators, to me it's just easier to use your calculator. So distribute 0.25, so that's 0.25x minus 0.75 plus 0.08 equals 0.15x. combine like terms, negative 0.75 plus 0.08. Bring down my 0.25x minus 0.67. Okay, so I usually like to put my variables on the left and my numbers on the right, but for this one it's easier to go ahead and subtract 0.25x to both sides. So I get negative 0.67 equals negative 0.10x, and then divide by negative 0.10. And that gives me x equals 6.7. Okay, so on this one we're going to distribute 5. Okay, and you should be kind of looking at this one as you're working it and notice that you've got 5x on the left, 5x on the right. So something's going on there. Let's continue combining like terms. 15 minus 3 is 12. Alright, so notice I have exactly the same thing on the left as I have on the right, or it's identical, and that should tell you that it's going to be an identity. Okay, and you can stop right there and just say infinite solutions or identity. You're definitely welcome to continue solving this out, and you'll see that everything's going to cancel. And 12 equals 12 is a true statement, so this is infinite solutions. And it is an identity. Okay, so the next type of linear equation we're going to look at are linear absolute value equations. In general, every occurrence of an absolute value term in an equation leads to two equations with the absolute value signs removed. As an example, the absolute value of ax plus b equals c means that ax plus b equals c, or the negative of ax plus b equals c. The easiest way to see this is to understand the definition of absolute value. So if I have the absolute value of x is equal to some positive number, like 3, well, x obviously is going to be 3 because the absolute value of 3 is 3. But we also have to consider the possibility that x is equal to negative 3 because the negative absolute value, or the absolute value of negative 3 is also 3. So when we're solving these, we have to consider both the positive and negative of that, because the definition of absolute value is the distance from 0 on the number line, and both of them have a distance of 3. Okay, so a word of caution, a word of warning: the apparent solutions obtained by the previous method may not solve the original absolute value equation. Absolute value equations are one class of equation in which it is very important to check your final answer in the original equation. An apparent solution that does not solve the original problem is called an extraneous solution. Now, in absolute value equations, this only occurs whenever you have the absolute value equal to a negative number. Okay, we don't have negative distance, so when we come across one of those, we'll talk about it. All right, so let's go ahead and solve our first example of absolute value equations. And I'm going to kind of skip a step on this just because it's easier to teach it this way. So we have two cases. So case 1, 3x minus 2 is equal to negative 1. Now, this is the same thing as saying that 3x minus 2 is negative. I've just moved it over to the other side already. And then case 2, 3x minus 2 is equal to positive 1. Okay? Every time you work an absolute value equation, you need to work two cases. A student taught me one time, they learned it. If you see two bars, remember to do two cases. Okay, so let's solve the first one. I'm going to add 2. So 3x equals negative 1 plus 2 is 1. Then divide by 3. So x equals 1/3. In the second case, I'm going to add 2 as well. So 3x equals 3. Divide by 3. X equals 1. Now, you should always check your solutions, but like I said before, in absolute value equations, the extraneous solutions occur whenever we have the absolute values equal to a negative. But to check this, you simply plug in each answer, make sure that it works. All right, so now our next example has an absolute value on both sides. So we're going to set this up with the two cases as well. We don't have to do 4 cases. If you did 4 cases, you would still get the same solution set because you would have repeats of the same solutions, and those would be extraneous. Okay, so x minus 4 is equal to negative 2x plus 1. That's our first case. Or x minus 4 is equal to positive 2x plus 1. So we always look at the negative case, the positive case, and it doesn't matter which one you do first. So I'm going to distribute my negative to get rid of parentheses. And then combine like terms. I'm going to add 2x. And then add 4. And then divide by 3. So I get x equals 1. And then for this one, I'm going to subtract 2x. And I get negative x. Minus 4 equals 1. Add 4. Negative x equals 5. Divide by negative 1. X equals negative 5. Okay, so our next example has a positive 5 on the same side as the absolute value. All the other examples, the absolute value has been sitting there all by itself. So we need to isolate the absolute value before we move forward so that we can do our two cases. But whenever I subtract 5, I get the absolute value of 6x minus 7 equals negative 2. Now, if you think about this logically, we're taking the absolute value of some number and we're stating that it's equal to negative 2. And this is not possible because it's the distance from 0, and we can't have a negative distance. So this is one where you're going to get extraneous solutions if you don't remember that it can't equal a negative and stop. Um, the solutions you get, you're going to solve solution. You're going to find solutions for this, but if you plug them back into the original, they're not going to work. Okay. This is an example of what they were talking about in that note above, checking your solutions to make sure they work. But I want you to practice noticing that it's an absolute value equal to a negative, and that's not possible. And so stop there. There is no solutions. All right, so the last thing that we're going to talk about in this section is called literal equations. And a literal equation is where we're given a formula and we're asked to solve for one of the variables. So this is just moving things around so that we get an equation that is set equal to one of the variables. And this is a useful tool when we're solving different kinds of equations that involve formulas and plugging in things, substitution, etc. Um, I'm going to go ahead and show you a couple of examples of these, and that'll be the end of this section. So for this one, I don't know if you recognize this formula, P equals 2L plus 2W. This is the formula for the perimeter of a rectangle, and they want us to solve it for the width. They want to solve for W. So let's go ahead and dive in. So to solve for W, I'm trying to get W by itself. So I want to get rid of things that are around it, so I'm going to subtract 2L. So P minus 2L equals 2W. And what makes these different is that there's not much arithmetic involved. I can't actually find a numeric answer. We're finding a new formula. So divide by 2. So W is equal to, I'm going to rewrite this as P over 2 minus 2L divided by 2 is just going to give me L. And you're done. All right, so this next one is A equals P times 1 plus R over M to the M times T power. And they want us to solve this one for P. You probably don't recognize this one, this formula, but we are going to talk about it later on in this course. This is the formula for calculating compound interest. A very useful formula for pretty much everybody because most of us are going to buy things on credit, and this is the formula that is used to calculate the interest on a loan or a savings product or whatever. But they want us to solve this for P, so this one's pretty easy to do. So A equals P times 1 plus R over M to the M T power. I need to get P by itself, so I'm simply going to divide by 1 plus R over M to the M times T power on both sides. So P equals A over 1 plus R over M to the M times T power. Okay, and this formula is something that we'll actually use later on whenever we're trying to calculate the principal on a word problem. So it's a good one to have in your notes. All right, so our last example is S equals 2 pi r squared plus 2 pi r h, and they want us to solve for h. Now this formula, you might recognize parts of it. Maybe you remember what this formula is for, but I'm going to go ahead and tell you. It is the surface area of a cylinder. Remember that the cylinder has bases that are circles, so, and there's two of them, so 2 pi r squared, that's the area of those two circles. And then 2 pi r h is the distance around the circle times the height. All right, so they want us to solve this one for h. So the first thing I'm going to move is my 2 pi r squared. So I'm going to subtract that from both sides. So s minus 2 pi r squared is equal to 2 pi r h. And then divide by 2 pi r. So h equals s over 2 pi r minus, and then if you divide this, the second part of the fraction, the 2's cancel, the pi's cancel, and one of the r's cancel, so we just get minus r.